Sometimes in our algebra we will see absolute values turn up. So let's have a little think about absolute values. So we can think of absolute values in two ways. We can think of it as in terms of algebra, or we can think of it in terms of geometry. And I might just get a bit of scrap paper here. That's what I'll do. So in the algebraic version here, if I said to you, what is the absolute value of -3? Most of us just say, yep, that's 3. Right? It's the magnitude of the number, if you like. Likewise, if I said to you, what's the absolute value of 3? You would also say that is 3. So algebraically, we can express that as, here, if I have the absolute value of A, well, if A is negative, it's got to come out to be positive. But if A is positive, it's just itself. So what we write, we say, look, the absolute value of A is just the number itself, if A is positive, whereas I've got to multiply by -1 if A is negative. So there's us saying what we intuitively think in mathematical notation. So that's our algebraic way of handling the absolute value of a number that we don't know what it is. All right? And so that's what we have here. There's our algebraic definition of absolute value. So it says, get your number, check which one of these is true, and then apply the appropriate rule. Right? The rule depends on whether A is positive or whether it's negative. To a mathematician, this looks really simple. To people just beginning, it looks overly and unnecessarily complicated. But it is a very precise and unambiguous way of writing absolute value when you don't quite know whether A is positive or negative. Geometrically, we can think of the absolute value as being the magnitude of the number, and we might say this. If we had a number line, 0, 1, 2, 3, 1, 2, 3, -1, -2, -3. So here I am at 3. We think geometrically of the absolute value of 3 being its distance from the origin. That distance there is 3 units. Likewise, the distance of this one from the origin is 3 units. And so we say the absolute value of a number is how far it is away from 0. And that's our geometric interpretation of it. And so sitting here, hopefully that's what it says. Geometrically, the absolute value of A is the distance of the number from the origin. So there is our algebraic version. Algebraic. And this is our geometric way of thinking of absolute value. Now, remember algebra is working with numbers, except we don't know specifically which number. And if you have an algebraic expression involving absolute values, there's a few properties of this number here that we can use. And so let me highlight this. We use these properties when we're rearranging algebraic expressions. These properties hold for no matter what number A or B are in here. So these relationships hold for all, so I'll say these hold for all values of A and B. Of A and B. And they're useful in algebraic rearrangements, if you like. For example, if I have two numbers and I multiply them and then take the absolute value, I get the same number if I take the absolute value of each and then multiply that. That always holds. And I would suggest to you, if you just take a few numbers and substitute these in, you'll begin to see that, yes, they make sense. Okay, they all seem reasonable in there. The biggest thing that students or beginners, L-platers, people with their L-plates on, have is this one down here. the absolute value of A plus B is not the same as the absolute value of A plus the absolute value of B. I have seen students 1,000 times try to do that simplification. It's not true. You can't do it. And we'll see that down here in this example. So let's do this example, in fact. So A says, evaluate this expression using 18 and minus 9. Now, here this expression is the absolute value of A minus B minus the absolute value of A minus the absolute value of B. So let's just have a little think about that before we start. If this was true here, if the absolute value of A minus B was the absolute value of A minus the absolute value of B, that number and that number would be the same and we would get 0 here. Let's put the numbers in and see what happens. So in here I have 18 minus 9, and here I have the absolute value of 18 minus the absolute value of minus 9. So I've substituted in A equal to 18, B equal to minus 9. Let's do the arithmetic now. 18 minus minus 9 is 18 plus 9, that's 27. So that's the absolute value of 27 minus, now the absolute value of 18 is 18, the absolute value of minus 9 is plus 9. The absolute value of 27 is 27. 18 minus 9 is 9. And so the end result out of all of that is 18. Clearly not 0, in fact. So you can see here the absolute value of A minus B is not the absolute value of A minus the absolute value of B. Yes? The absolute value of minus 9 is plus 9, because that's its distance from the origin.
Yeah, it's just 9.
Yeah, and so you end up there with 18 minus 9.
Yeah.
Got it? Cool.
Yeah, normally we get a plus. It's just 9.
That's right, because you've got to do the absolute value before you do the subtraction. Yes, yes, that's the key point there. Yep, that's right. So, yes, this says we have to actually work out the absolute value before we do this subtraction here with that minus sign. Yeah. Yep, that's good point. Okay, and the last part says, here the absolute value of A divided by B plus the absolute value of A on the absolute value of B. And so here, the absolute value of 18 divided by minus 9 plus the absolute value of 18 on the absolute value of minus 9. So I do all my well, in this case I do the division first, and so that's minus 2 there. But in the next term, the absolute value of 18 is 18, the absolute value of minus 9 is plus 9. The absolute value of minus 2 is plus 2, 18 divided by 9 is 2, I end up with 4.